2.2, slope and rate of change. The slope m of a non-vertical line is the ratio of vertical change, the rise, to a horizontal change, the run. So essentially you're finding the amount of change in rise to the change in the run. Rise is the change in the y's to the change in the run, the x's. And all it takes is 2 points, and the difference of the two y's divided by the difference of the two x's gets you the slope of the line. Here's the equation. Let's put it to use. Example 1. A skateboard ramp has a rise of 15 inches and a run of 54 inches. What is the slope? Well, they've already given you the difference of the 2 points. They're saying from here to here is 54 inches, so that's the difference, as well as the rise from here to here is 15 inches. So you don't have to use the full formula, because they've already did the differences for you. But you just put the rise over the run. So m equals 15 over 54. And to simplify that, you don't even know. Put in a calculator, see if you can simplify those, maybe divide by 3. Anyway, example 2. What is the slope of a line passing through 2 points? And then let's put these into the formula. Please, to make it easier for you, I recommend that you label the points, x1, y1, x2, y2. And we'll see what the slope is. So here we go. Slope equals, it's y2 minus y1. So it's negative 1 minus 3. And 2 minus negative 1. 2 minus a negative 1. I simplify, I will get, I'll just go work down here, negative 4 over 3. So slope is equal to negative 4/3. That would be A. If you're not convinced that it doesn't matter which point it is, if I make this point 1, this point 2, I'll put them in the equation and see if we get the same answer. So it'll be then 3 minus a negative 1. So 3 minus a negative 1. And negative 1 minus 2. Negative 1 minus 2. This gives me a 4 over negative 3. Which, yeah, it gives me the same answer. The negative's on the bottom as opposed to the top. Doesn't matter where the negative is. They're both negative. All right, we'll do some other examples later. At the bottom of the page, classifying lines by slope. The slope of a line indicates whether the line rises from left to right, like the first one, falls from left to right, is horizontal or vertical. This is a positive slope. When you're going from left to right, you're going up. Negative slopes coming down from left to right, have a negative number to it. A zero slope, literally the m equals 0, is a horizontal line. And a undefined is going to be divided by 0. 0 in the denominator, and undefined. Let's try some examples with this on page 2. Example 3. They give us 3 pairs of points, and we'll find the slope of all these, all 4 of them, and then we'll classify whether it's rising, falling, horizontal, vertical. I think they give us one of each of the samples. I'll label the first one with x1, y1, x2, y2, but from then on you do enough of these, you don't need to do all that. X1, y1, x2, y2 into the formula. M equals, so it's going to be 1 minus 1, 3 minus negative 5. That equals 0 over 8. 0 over anything is 0. That's a horizontal line. Slope of 0. All right, for letter B, the slope's going to be equal to negative 4 minus 0 and 2 minus a negative 6. That gets me negative 4 over 8. It's negative 1/2. That's a negative slope coming down left to right. Letter C. So the slope is equal to 8 minus 3, 5 minus negative 1. That is going to be 5 over 6. That gives me another positive one. Okay. Last one. Slope of D is You get -1 minus 6. 4 minus 4. You get negative, what, 7 over 0. The 0 is undefined. It's going to be a vertical line. All right, let's talk about parallel and perpendicular lines. Recall that two lines in a plane are parallel if they do not intersect. Two lines in a plane are perpendicular if they intersect and form a right angle. Slope can be used to determine whether the two different non-vertical lines are parallel or perpendicular. So here's what you got to know for this. For parallel lines, the two slopes not touching have the same slope. So M1 of line 1, M1 equals M2. Two lines have equal slope. To be perpendicular, just by looking at these two lines, there's line 2, line 1. One's always positive, one's always negative. So the signs will be the opposite. And incidentally, their value will be the inverse. And we'll show you a shortcut outside of these two equations. So you can multiply the two slopes. If it's equal to -1, they're perpendicular. Or one of the slopes is equal to the negative of the inverse of the other slope. And this would be probably the easiest way for you guys to determine a perpendicular slope. Let's look at some examples. All right, example 4. Two lines. We'll find both slopes and then determine if they're parallel, perpendicular, or neither. So we will take this first one, M1 equals -1 minus 2. And 0 minus 2. 0 minus a -2. That will equal -3 over a +2. The second line, 3 minus -1, and a 2 minus a -4. Looking at this, we have 3 plus 1 is 4, and 2 plus a 4 is 6. That's 2/3. So that's second slope. Here's the first line slope. Look at the two slopes. If I multiply them together, -3/2 times 2/3. Let me do that for you down here. So -3/2 times 2/3, you get -6 over 6, which equals -1. So they are perpendicular slopes. Letter B. Find the slope of 1. So measure the slope of line 1. -3 minus 2. And 4 minus 1. That's a -5 over 3. Slope 2, -2 minus 3, -2 minus 3, -1 minus 4. Geez, that's a lot of negatives. This gives me a -5, and this gives me a +3. Those two are exactly the same. When the slopes are equal, you have parallel lines. 5, solving a multi-step problem. It's a word problem. Use a diagram which illustrates the growth of giant sequoia to find the average rate of change in the diameter of sequoia over time. Then predict the sequoia's diameter in 2065. So for this, we need to have rate of change. Time, the time after the years, is always the independent variable. That always goes on the bottom, like x for slope is on the bottom is the independent variable. So if we say 2005 minus 1965, we get the change in time. Likewise, we get the change in the growth. So in 2025, it was 141 inches, I think, and 137 back in 1965. Subtract those, we have 4 divided by 40, or 0.1 inch per year. So that's the rate of change for the sequoia for those 40 years. Well, now they want us to determine what it's going to be in 2065. Well, if in 2005 it's 141, we're going to be going 60 years between 2005 and 60. So 2065 minus 2005 gets us 60 years times the 0.1 rate, 0.1. That's going to equal 6 more inches of diameter. So by then it should be, the 141 plus 6. It should be 147 inch diameter in 2065. I don't think I'll be around at that time.